All right, lesson 3, Earth's moving plates. So in this lesson, you should be able to discuss the theory of plate tectonics. All right, so the evidence for continental drift and seafloor spreading caused old theories to be discarded. Once Wegener had kind of thrown out the idea, and then Harry Hess could explain why it was happening, they finally started believing that this could happen. We got the theory of plate tectonics, which combines continental drift and seafloor spreading. So both of Wegener's and Harry Hess's ideas were brought together to create the theory of plate tectonics. So this helped explain how Earth has evolved from Pangaea to the current formation, so from that giant landmass to breaking up into the separate continents that we know today. Just to discuss, a plate is a moving irregularly shaped slab that fits together to form the surface layer of the Earth. So in the background of this slide, you can see the red lines would represent our plate boundaries. Now, this doesn't have every single plate on this image, but most of the main plates are shown, and we'll get into that more. Tectonics is the branch of geology that deals with movements that shape the Earth's crust. It helps explain formation of mountains, volcanoes, earthquakes, and other landforms. And the theory of plate tectonics helps explain how and why life on Earth has evolved. Okay, so the lithospheric plates. We talked about the lithosphere in the last unit. The lithosphere is that topmost solid part of the Earth. It's made of the... Why don't I have that in here? If you want to add to this, it is the crust and upper mantle, which you learned last unit. It makes up the tectonic plates. It's made of continental and oceanic plates. So whether the plate has land on it or whether it has ocean above it, that determines what type of plate it is. There are 7 major plates. There's the Pacific, North American, South American, Eurasian, African, Indo-Australian, and Antarctic. So notice that they're named after basically the areas where they're at. Here's Australia. This is the Indo-Australian plate. The North American plate has North America in it. You can see the white lines in the background are like the continents, and then the colored plates are the tectonic plates that we're talking about. Many other smaller plates exist, and some that aren't included on a map because they're so small. And plates can be created and destroyed. It all depends upon the plate movement. So we can have some plates that existed long ago, which can explain why mountains are in certain areas, but like there's no plate boundary there. So to us now looking at it, it's like, okay, how could that be? Well, there must have been a plate boundary there in the past. Okay, lithospheric plates. Plates move on average several centimeters per year, which is about the speed that fingernails grow. So they don't move very fast. Plates weighed down with continents move only millimeters per year. So there are some slight differences in how fast they move, only because of like how heavy they are.